Hello everybody, and welcome to the first video on functions. So functions is the next big topic of the course. It's a topic that is on par with loops and vectors in terms of importance for actual computer science. So like loops, like vectors, you simply can't do actual computer science in the real world without the concept of a function. So this video is an introduction to them, so basically I will focus on what they are and I will do some introductory, more basic examples. So what is a function? A function is a block of code that performs a specific task or perhaps multiple tasks. If your code needs to perform a task more than once, using a function enables you to write code for this task only once. So the idea is that you can streamline your code by taking this task that you need done multiple times, writing that code exactly once, and then just calling on the function to use it. So let me just make that slightly more concrete. Here is my nim program. This is on Moodle, the nim program from a previous video. So you ask the user how many piles of rocks they have, and then ask them how many rocks are in each pile, etc. In this program, there are several specific tasks that I have to do over and over again. So let me just focus on, this one. What is that for loop doing? It is printing the game board to the screen. All right, so right here I say, okay, here's the starting configuration. But anyway, this for loop here is printing the game board to the screen. That's a task I need done. The task of printing to the screen the game board so the user can see what's happening. That task occurs right here. It also occurs, let me keep scrolling. Okay, here's the game board now. Occurs here. And then if I keep scrolling, scroll. So after the computer's turn, does it again. Okay, that's the same task that I've done 3 different times. Now, in this case, the task doesn't require much to type. Like this is just a little for loop with a single command inside of it. So it's not that obnoxious to repeat this task over and over again. But just imagine this task required like 20 lines of code. It's really inefficient and obnoxious to have to keep writing that same 20 lines every time. So what I would like is, let me go all the way back up to the top. Where's the first time I do this task? Right here. No. First time is right here. Okay. What I would like is something like the following. Instead of that for loop being right there, I just want to type in plain English, print game board. Whatever, right? I want a line of code that looks like that. And it's yelling at me because it doesn't understand me, okay? But I want it to understand me. I want to teach it what that means. What would it mean to teach the computer what this means? That would mean teaching the computer this for loop. So I would just teach the computer that, hey man, when I say something like this, what I'm really asking you to do is this. So not only would that streamline the code some, it also makes the code more readable in English, right? So instead of this for loop here, I would like to write print game board right here. Right, so this is gone now, right? I would like that to just be gone. Let me put it back. And then where's the next one? Okay, here's the game board now. I'd like to just write print game board and just have it know what that means. Just do it, And then there's one more instance right down here. Right here. Okay. So in other words, what am I saying? I'm saying I would like to just take this for loop structure that does print the game board and just collapse it down to a single line of English. Okay, so I would want to teach the computer what this task is so I don't have to write the same line of code all the time, this for loop. That's what a function does for you. You have a task that you want done, you write the code for it just once. Teach the computer what that code is. So teach the computer what you mean by the English phrase print game board, and then the computer can just reach for that for loop every time. So what this allows you to do is just to symbol your program up from the bottom. So just identify what your tasks are, write them as functions, and then just use them as you need them. So that was all pretty high level, okay? It's not clear that this means anything to you, and that's fine if it means nothing to you. It will become clear over the next couple of weeks what this is all doing for you, okay? In particular, by the end of this video, you still will have no idea how useful functions are. Okay, it takes some time. Functions generally take time to get used to, just like loops, just like vectors. You will not understand them after a day or two. Okay, it takes a couple of weeks at least. Okay, so before I show you how to actually build these things in C++, let me just focus on the definition of function writ large. Okay, so what is a function, computer or not, right? So C++ or not, what's a function? A function is an abstract machine. Okay, that's what it is. You give the function some stuff, some inputs. The function does some stuff with those inputs. It does something. Who knows, right? Oh, I got a virus update, okay. And then what the function does is it spits out a return value according to some rule that you've initialized or that you've built. Okay, so here's a function. F of x equals 2 to the x. What is this function doing? It's the function that when you input a number, like say 3, the function does 2 to the third, and it gives you 8 back. Okay, so let me say that again. This right here, it's a machine, an abstract machine. You feed inputs into it, like the input 3, and then the rule that it uses is take that number 3, take 2 to that number. So this number 3 becomes a power of 2. So you do 2 to the third, and the function outputs to you 8. So here's an input, here's an output. This output was calculated using this formula, using this rule. Something slightly more familiar, perhaps, addition. What is addition? Well, fundamentally, addition is a machine that you hand two numbers, a and b, and the function just gives you a return value of a plus b. So if you hand that machine the numbers 2 and 7, the machine gives you 9 back. Okay, so again, you can think of addition as a machine where you hand it two numbers. According to the addition rule, the function gives you a return value back. It gives you 9 back in this case. Here's another function. Think about an averaging function where you hand it 7 numbers. So a function that inputs 7 numbers and returns their average. You have to hand that function 7 pieces of data, and what the machine will do for you is give you back their average, like this. So you input 7 numbers, and what does the machine give back to you? A single number, the average of those first 7. So here's just a schematic of how a function works. You feed things into it, right? In this particular case here, you had to feed in 7 numbers. With addition, you have to feed in 2 numbers. With this 2 to the x guy, you only feed in a single number. Okay, but whatever. You feed things into it. The function then does something. And that something is up to you. You know, in this example here, you averaged. In this example here, you added. In this example here, you exponentiated. But whatever, you know, it's up to you. Based on this rule, the function gives you something back. A single output, at most one output. That's what a function is, mathematically speaking, like philosophically speaking, okay, regardless of coding. So before I show you how to code these things, let me just once again emphasize globally what a function is and how they work. You give the function a bunch of stuff. The fancy word for that stuff is parameters, but you could also say a list of inputs. Okay, you could give it one thing up to 1,000 things, it doesn't matter. The function takes those parameters and does something with them. And then it gives you something back, returns something. The function performs its task based on what you've told it to do. Okay, you tell the function what it does. You can tell the function to average things. You can tell the function to add things, whatever. So when we build a function, which I'll do for you in a second, we have to do a lot of things. The first thing we have to do is name the function. So like here, this function that adds things is called plus. Okay. This function here that averages things, I suppose you could call it average or AVG or something, I don't know. This function here is called f. That's its name. That's how you would refer to it. Okay, so you have to name the thing, just like you have to name a variable. You know, it's a thing in memory. You have to tell it what it's called. You also have to tell the computer how many things you're going to input and what kind of thing it is. So in this case here, we would specify we're handing the function an integer, I guess. But if you wanted to hand it decimals, you would specify float. In this example here, if you're thinking of all 7 numbers as integers, you would have to tell the computer that. But again, you could also think of these as floats if you wanted to. You know, if your goal is to average seven decimals, that's fine. But you have to tell the computer this, okay? You have to tell the computer the kind of thing you are feeding into the function. You can feed the function strings. You can feed the function characters. You can feed the function vectors if you want to. You can feed functions anything, but you have to tell the computer what you are feeding in. Furthermore, you have to tell the computer the kind of thing that it's going to give back. So in this example of averaging, let's say these are whole numbers. You would have to tell the computer, I'm going to hand you 7 whole numbers. What you are going to hand back to me is a decimal, most likely, right? When you divide by 7, you are probably going to get a decimal. Okay, so remember, the computer is an idiot. Okay, the computer knows nothing. You have to tell it everything. So you have to tell the computer the name of this function so you can call on it. You have to tell the computer what you're handing the function and what kind of things those are. And you have to tell the computer what it's going to give back to you. Okay, so basically, you have to tell the computer everything about this function. So let's get concrete with this. Here's an area calculating function. It computes the area of a circle for you based on a radius of the circle. So this function here, how does it work? You feed in a radius. The rule the function uses is it takes the radius and squares it and then multiplies by pi. So what it gives back to you is an area. And I'm going to call the function area. Okay. So let's just say that multiple times during your program you want to compute areas of circles, whatever. I suppose you could do this every time, right? But why not just make things more English readable and write this instead? Give me the area for a given radius. Just compute that for me. So what would this look like? Okay, in the code itself. So here's our first example of building a function in the code. Let me get rid of all of this. All of this is gone. Okay. So you have to teach the computer everything about this function. You have to teach the computer its name, what kind of thing you're inputting, what kind of thing it's outputting back to you, etc. Okay? Here is the general schematic of how you build a function. First, the first thing you do is tell the computer what kind of thing it's going to output to you. What kind of thing is the return value? Okay? So let's think about that. If you feed in a radius here, what kind of thing does the computer give back to you? Well, even if the radius is a whole number, like you feed in 2 or something, pi times something is generally speaking a decimal. Okay? So this function is going to hand back to you a decimal. So because of that, I'm going to write float right here. So the first thing you do is tell the computer what kind of thing the function will give back. Then you tell the computer the name of the function. Okay? Then you tell the computer what kind of thing you are handing it. In this case, you are handing the computer or the function just a single value, and let's just assume that we're only dealing with integer radii. Okay? So we tell the computer, wait, why is it mad at me? Okay, so I'm going to use it later. That's what it's telling me. Anyway, there's nothing wrong. Okay. So what I've told the computer here is, hey man, I'm building a function. That function is called area. That's its name. What I'm going to do is hand that function a radius that I'm thinking of as an integer, and then you, computer, are going to do something that requires you to hand back a decimal. So now the function is declared. Okay, so I've told the computer, like, hey man, be ready. I'm going to create a function. Just like in main, if you write this, right, you've declared an integer. So you've told the computer, like, hey bro, you be ready for me to do something with this x, and when I do something with it, it's going to be an integer. Okay, that's what you've done here. To actually build the function, what you'll do is you'll come down here, you'll copy and paste this declaration, and now the semicolon is gone. Okay, semicolon was just for declaration. Now what you do is you actually build the function, so now you actually have to teach the computer what you want to have happen. Okay, so what do you want to have happen? What you want to have happen is you accept a radius, and then you need to do radius squared times pi, and then give that back. So the way that looks is like this. Give me back, please, radius times pi. So that phrase return, okay, that's, oops, the computer doesn't know what pi is. So let me just 3.1415. So this word return, that's a special word. It's reserved in C++. That means give me that thing back. I'm handing you this radius, okay? I want you to give back to me radius times pi. So how does that work in the code itself? Well, let me just go back up to main and get a radius from a user. So like, what's the radius of your circle? You know, whatever. Grab the radius from them, okay? Now in main, you could write a piece of code that looks like this. Print to the screen for me the area for that radius. Okay, so what's happening here? Main is doing what it always does. It just starts at the top and reads its way down. So I declare an integer r, I print to the screen whatever, I then get that radius from the user. Now, what is this line of code doing? It's printing to the screen something. What is it going to print? Well, this r value here, whatever it happens to be, 5, 6, 7, whatever, what literally happens now is the program jumps from main down to this function. So you are literally going to jump from here to here. Whatever value is inside of r right now, so the value could be 4, could be 5, whatever, the user gives it to you, right? That value gets passed on to this variable named radius. So the value of r here gets overlaid on top of the variable radius. So now radius takes on the value 5 or 4 or whatever was handed. And then this function gives back to you radius times 3.1415. So if the user typed a 5 right here, that means this guy has value 5. So that 5 gets passed on to this other variable radius. Then you compute radius times pi and give it back. So let me just run this code. Wow, that's taking a long time. Okay, why is this taking so long? All right, whatever. So what's the radius of your circle? I don't know, 4. So what happens is that 4 gets read in right here, okay? So r has value 4. That 4 then gets passed to this variable radius here, and then we do 4 times pi, and we give that back. And that's what this becomes. This is the output for the input of a radius value of 4. Okay, so this is running really slowly. So let me just exit out of this. You guys use Eclipse because the computers are PC. I use a different compiler when I'm not normally doing this. The Mac compilers are all better. So let me just use the Mac compiler, see if it runs any faster. Okay, so that ran faster. So let me just type in another radius, 5. So 5 times pi is that. Okay. So back up here, you can do things like, I don't know, float area or something, right? Just create something for area, and you can write lines of code like this. I want A to be area of r. So what happens here? I feed r into the function area. Where I'm given back is a decimal. So now I could print right here. I could just print A instead, and it would do the same thing for me. Oops. So if I type in 5, it does the same thing, okay? So here's our first example of a function. Here's how they work. Now, You might be thinking, of what use is this? I could have just done this in main, right? I mean, this seems awfully complicated just to do this one little thing, right, of computing radius squared times pi. And I agree with you. It is awfully complicated to do that. But notice one advantage already. One advantage is that we've made main itself read more like English, which is an advantage, if you're trying to read the work of somebody else. Also, keep in mind, this is a tiny introductory example, okay, which may or may not even be clear right now. In general, these functions are much longer, and so you're saving yourself time by only writing this line of code once, okay? So suppose, we want the user to enter another radius. We could then print to the screen that guy's radius, right? And then maybe we want to get a different radius from them. We could then print to the screen again, right? So we don't have to write this computational line of code every time if we've outsourced it to a function. You can just keep doing this over and over again. So that's the power of a function. We've taken this little line of code here and saved ourselves some time by not writing it every time. We've outsourced it. Okay, so let me show you just a few more examples. So let's write a function that returns the average of two integers. What would that look like? So back up here, I first have to think about what the function gives back. Averages are, in general, decimals. And then I'll call the function average. And in this case now, I have to hand the function two integers. So I'm going to write it like this. So again, what have I done? I've taught the computer there's a function named average, and I'm going to hand it a couple of integers. What it's going to give back to me is a decimal. So once I've declared it, let me just build the function down here. You always build below main. Okay, well, what should I give back? I should give back a plus b divided by 2. That's what an average is, right, of two numbers. So back up here, let me get rid of all this. Int number 1, number 2. I can grab them from the user. Okay. And then what I could do is I can print to the screen. Oops. Make sure things match. I can print to the screen like, hey man, what was the average of those two numbers? And what happens here? Now, as soon as main sees this word average, it jumps down here. And then it does whatever you've told it to do down here. So the value of num1 gets passed to this variable a. So if num1 is 7, a is now 7. The value of num2 gets passed to this variable b. So if the value of num2 is 8, b is now 8. And then what do? 7 plus 8 divided by 2, and we give it back. Okay, so let me just enter 7, 8. And it tells me the average was 7.5, Let me just do, I don't know, 10, 16. Average is 13. So again, if you wanted to compute averages all the time, you could write lines of code like this all over main, or you could write them once and then just call on it whenever you feel like. And again, main now is more readable. Average of these two numbers. Right? It's clear what's happening. Let me close with a couple of examples of Boolean functions. So my next example will be to write a function that determines whether or not a number is even. Okay, so how would you do something like that? Now, okay, let me just call it is even, because that's what I want to check. So I'm going to name it first. What do I want to hand to this function? Well, I need to hand it an integer, okay? What kind of thing will this function hand back? Well, what seems most natural to do is, if the function is even, if the number is even, give me true back. If the number is odd, give me false back. So let's return either true or false based on whether the number is even or odd. So what would that look like? Okay, so how do we test if something is even? If a percentage 2 is 0. Right, if a is a multiple of 2, then a is even. And in that case, what should I do? Well, now the statement is even. That's true. Okay. Otherwise, oops, if it's not even, it's odd. So the statement is even is false. Okay, so return false. So I feed a number in. If that number is even, then is even is true. If the number is odd, is even is false. So now back in main, I can do things like this. Grab a number. Okay, so if is even a. So in plain English, what I'm saying is, if that number a is even, if that's a true statement, we could print to the screen, even number. Otherwise, you can print odd number. Okay, so what's happening here? You grab a number from the user. The number is like a 7, whatever. You feed 7 into the function, and so now we drop way down here. So now the value of this a is 7. Then we just check, is 7 even or odd? If 7 is odd, which it is, we return false back. Therefore, this statement is false. So I'll go into the else block and print odd. Okay, so let me just put like 7 in there. It says odd number, okay? What if I put 10 in there? It says even number, okay? So again, what's happening is, whatever the value of this number is, you're feeding it into the function is even. So you're feeding a 10 in there. So what happens? This value of 10 here gets placed on top of this a. So this a now has value 10. And then you say, if 10 percentage 2 is 0, which it is, you get true back. Otherwise, you get false back. So here we built 3 different functions for 3 different tasks. This task is computing an area from a radius. This task is computing the average of 2 whole numbers. This task is checking whether or not a number is even or odd. Okay. So let me briefly finish up the video with one more Boolean function. So let's write a function that determines whether or not a quadratic equation has real solutions. So just if there are real solutions, we'll say so. Otherwise, we won't say so. So you guys did a homework exercise on this before, but let me just recall certain things here. This quadratic equation, where a, b, and c can be any numbers, has a real solution if and only if what's under the square root is not negative. So on some level, all we have to do is build a function that tests whether this right here is positive or negative. Okay, so let me just back up here, declare my function. So the statement has real solutions. That's either true or false. So we're just going to test whether or not it has real solutions. We're not solving for them, okay? We're just testing whether or not real solutions exist. So that's either true or false. What do we have to hand to this function? We have to hand it all 3 of the parameters for that equation, right? We have to hand it a, b, and c. If we don't hand it all 3 of those things, it doesn't know what quadratic equation we are talking about. Okay, so once I've declared it, let me go all the way down here and build it. Okay, so has real solutions. So we should return true if what? If b times b minus 4 times a times c. If that's bigger than or equal to 0, we have real solutions. So has real solutions is true. Otherwise, stop. Otherwise, we don't. Otherwise, we're taking the square root of a negative number, and we don't have real solutions. So let me come back up here, and let me now just grab 3 numbers from the user. Okay, so now let me change this if statement. If has real solutions, a, b, c. So I feed all 3 numbers into the function. If that's a true statement, then we should print to the screen, has real solutions. Otherwise, though, it doesn't have real solutions, so no real solutions. So let me run this. let's say that the leading coefficient is 1, then 0, then 1. It says no real solutions. And that is correct because the equation x squared plus 1 equals 0 has no real solution. Okay, so you can confirm this for yourself using a quadratic equation solver online or something. But if I do, I don't know, 1, 0, negative 1, it says has real solutions. And that is also true. X squared minus 1 equals 0 does have solutions. Okay, so again, what happens here? The user gives you 3 values. I then take each of those 3 values, A, B, C. This value of A here becomes this value of A here. The value of B up top becomes this value of B. The value of C up top becomes this value of C. And then we just check. Is B times B minus 4 times A times C positive or not? Positive or 0 or not? And if so, we give true back. If not, we give false back. Okay, so I'm going to put this code on Moodle so you can mess with it if you want to, all of these functions. Functions are hard, okay? So I don't know how easy you thought this looked watching me build these, okay? But they take quite a bit of getting used to. Writing them yourself, using them yourself, okay? I just use them pretty easily myself up here, you know, because I'm really used to them. So I was able to just use the functions up here. Being able to write them, keeping track of what you want them to do, keeping track of the syntax, keeping track of how to use them, all of these things take quite a bit of getting used to. Okay, so we will start getting used to these in class. Okay, and I'll see you then.